Let's do this. Number 17 and 18. We're going to use the method of y equals mx plus b. The reason why we use this is your slope. M is your slope. Okay? B is your y-intercept. Y equals mx plus b can solve any linear equation. If they give you 2 points, if they give you an equation that's not in y equals mx plus b form, it doesn't matter. If they give you a point in the slope, you can still use it. That's why I don't teach point slope. I don't teach all these other formulas. I teach one main formula, and that is y equals mx plus b. It's the goddess formula. This works for anything. Okay? The other thing is, learn the face. Negative slope, positive slope, nose, solution. Get it? Nose, solution. Okay? There is no slope when you have something like a board. No slope means it can't hold it. No slope means it will go forever. Zero slope. Okay? Zero slope. This is when x equals a number. This is when y equals. And there's your face. Okay? So once you learn positive, negative slopes, no slope, zero slope, okay, it becomes really easy to graph this stuff. Alright? Slope is the change in y over the change in x. In other words, rise over run. That means up and down, meaning up is positive, down is negative. Right and left, meaning left is negative, right is positive. Okay? So let's think about this. Number 17 is given y equals 1/4 x, and that's given. Right? Now, because it's in the y equals mx plus b form, it's pretty simple. I already know that it's plus 0. Definition of y equals mx plus b. That means that b is equal to 0, or in other case, the y-intercept. Okay? That means it crosses right here at 0. Now, the other thing I know is
What do you mean b is 0?
m, huh?
Why is b 0?
Well, what's adding to the x? Nothing, right?
I thought 1/4.
1/4 is mx plus b, right? So 1/4 becomes m. So your m is equal to what? Yeah, or 1/4, right? So that's your rise, that's your run. Definition of y equals mx plus b. So I'm going to rise 1, and I'm going to run 4. If I'm rising positive 1, I'm going up. If I'm running positive 4, I'm going right. 1, 2, 3, 4, and that's my point. From the last point, from not necessarily the origin, from the y-intercept. It just happens to be the origin on this one. Okay? And that's your line. It's that simple. Graphing should be easy. Don't make it hard. Okay? Alright, here's another one. Given. I'm going to move it over a little bit. So negative 20 equals negative 5y plus 6x. And that's given, right? But what do I want? I want y equals, right? And I don't want negative y, I want positive y, right? So I'm going to move the 5y. Okay? And in fact, I'm going to show you a little trick. I'm going to move the 5y and the 20 at the same time. Because I want the y over here and I want the number over there, right? So I get 5y is equal to 6x plus 20. Yeah? Now what did I do? I added on both sides, right? What's that called? Addition property of equality. Okay? Then what? I want y alone. How do you get y alone? Anna. Joshua. How do I get y alone? We did this first period, second period, right? If it's timesing, I divide, right? So, I'm dividing by 5, but everybody on the block gets a paper, right? Everybody over here. That means I have to divide this by 5 and this by 5. Everybody gets divided by 5. Alright? Division property of equality. Yeah? This 5 cancels, so I get y equals what? Y equals 6/5 x, right? Plus what? 4, right? Because 5 goes into 20 4 times. Yeah? Okay? Now, do I have my b? Do I have my m? Then I can graph it. It's that simple. What's my b? That's my starting point. What's my b? 4. Good. Alright, so b equals 4. That's my y-intercept, right? So definition of y equals mx plus b. So that's 4, 1, 2, 3, 4. And from that point, I'm going to do what? Yes, I'm going to go up 6, right? So this is my m. So I'm going to rise 1, 2, 3, 4, 5, 6, right? And I'm going to go where?
Over 5.
Over 5, good. 1, 2, 3, 4, 5, right? So right there. Now what if it's like this? It's not really looking good. So think about this. Is this the same? Is that the same? Is that still positive? Is 2 negatives make a positive? Yeah. That's the cool part. So now I can actually go the other way if I want to keep it in my frame. Does that make sense? So I could go down 1, 2, 3, 4, 5, 6, and then I could go left 1, 2, 3, 4, 5, right? And so this should match up. And if you notice, they go right through each other. Does that make sense? And so that way, if it doesn't quite fit on the graph that you have on your paper, maybe you can go the other direction. Does that make sense? So if one of them is negative, let's say you got negative 3 over 4. Isn't that the same to 3 over negative 4? You see what I mean? So then this would be down 3. So if we were at a point here, right? This would be down 3 1, 2, 3, right? 4. 1, 2, 3, 4. 1, 3, 4, right? Okay? Or it could be up 3. 1, 2, 3, and left 4. 1, 2, 3, 4. And see how those are in a line? Does that make sense? That is the one thing that blows students' minds when they're working with linear algebra. Is this, well, should I put the negative on top, on bottom? Does it matter? It doesn't matter as long as is it in one place or the other. Or in this case, that it's in both places or no place. Does that make sense? So that's kind of something new for you guys. I can see it in your eyes. That's why we're not on the board. This is why yes?
What's the point for the lower point? What
This
is
one?
it? Yeah,
So what is this point exactly?
that's this one.
Like, you want to know the point?
Like 5 and 6 or 6 and 6.
So we went down 6, right? 1, 2, 3, 4, 5, 6. So that's at negative 2,
Yeah.
right? And then we went left 5, right? So that should be at minus 5. So this point should be negative 5 and negative 2. Does that make sense?
Yes, got
Okay,
it.
cool. Great questions. Any other questions? Love ya. Always.
Love you too.
Right?